Up next is my fellow co-chair who needs no introduction, Saiyam Pathak, the head of developer relations at vClusters and founder of KubeCon. Today, Saiyam will delve into the ways in which Kubernetes and CNCF ecosystem have risen to the occasion, addressing the challenges of sharing GPU infrastructure across multiple AI teams. Let's welcome Saiyam to the stage.
Alright, so I'll try to fix the demo first and then we'll start with some of the things. So, I hope you're having a good time. So as you can see, right now the node is not ready, but it will be ready soon, hopefully. And once it's ready, we'll switch back and forth between the slides and the demo. So the demo, you have to trust me on a few things. First, the demo was working in the morning. Second, I do have a backup recording to show that the demo was working. And third, that hopefully it will take 6 to 7 minutes for this to get fixed automatically, hopefully, and then we should be able to work it out. But yeah, we are here to discuss some of the key things and one of the very cool projects. So I'll pick the Mumbai theme. You folks are very much familiar with what you are seeing on the screen. So every day, thousands and thousands of people are traveling through the train, and the train capacity is limited. Now, I believe that train is one of the most efficient shared infrastructure that you can think of. Each compartment is fairly used by the people to reach somewhere every morning or evening to the work or back home. So this particular thing you have to keep in mind, because when we talk about the compartment in the train, that compares to the GPU that we want to utilize to full capacity. So there are these Mumbai runs on three key things. They already run an AI factory within, and we need to learn from Mumbai how Kubernetes, along with its friends, can power the AI factory. So the one is the train, the Dabbawalas, and the Kalipili taxis. So we keep these three things in mind, and we'll get to that. Over the past few years, the discussions were like, people were building the platforms, how to build a platform, and then helping the developer ecosystem. Now, with the rise of AI applications, the enterprises, the conversations have changed. The enterprises have now, we have now purchased the GPUs. We have the AI teams who needs these GPUs in a very fair manner, so that they can do inferencing, they can do training and whatnot over their GPUs. Even there is a term called the AI cloud provider called the Neo Clouds who are building the AI factories. So what they have done is they are buying all these GPUs, and they also need to provide the GPU slice powered by Kubernetes to their customers instead of the raw GPUs. So the conversations have moved one level up from the developer platforms to the AI platforms that people are building. And this leads to something which is called the AI factories. So when it comes to production, you must have heard in the first keynote about inferencing. So inferencing is where AI meets production. And inference is something which, so Kubernetes is very good for CPUs. We all agree on that?
Yes.
Will you agree? Alright, so Kubernetes is good for CPUs, but is it the same for GPUs? Like, it has the auto scaling, it has monitoring, observability, everything inbuilt. But for the GPUs, when we say nvidia.com/GPU1, we want one GPU to be allocated to one particular user, but that user might not need the whole GPU. Similar to what you can see over here, that if we give one compartment to one passenger, there will only be 50 people traveling. So that's not the best shared infrastructure that we have built. So this is where there's a term called AI factories. So AI factories is something that was coined by NVIDIA, that plugging in the data center with electricity and data to produce tokens. You might be hearing a lot about tokens. You might be using millions of tokens yourself. So the AI factories to build is something that we are discussing today, and we'll see if Kubernetes have solved it with some of its friends. So one of the first projects, and I also run the script meanwhile. Okay, we still have node not ready. Okay, because we are not connected to the hotspot. Those are pure network challenges. Nothing wrong with the demo. Okay. So one of the projects that you have seen in the first keynote was HAMi. So, like I said, we cannot give every passenger its own compartment. What we need to do is we need to partition that. And there is this CNCF sandbox project, and actually it applied for incubation, and the incubation comment period is also open. So very soon it will be incubating as well. So HAMi is heterogeneous AI virtualizing the compute middleware. So it actually gives you the slices of the GPU and makes it available for Kubernetes to read. Like there are from a single GPU, like this is the NVIDIA DGX Spark. So this is a single GPU. So your HAMi is able to give the slices so that when Kubernetes sees, it is able to read it as there are multiple GPUs that can be consumed from a single GPU. And it has its own runtime path, own scheduler path. So it is able to schedule to the right workload and able to provide and does do stuff at the memory level from within the ecosystem. So this is where HAMi kind of comes in. And the next one, we are ready, at least. And now it should go on recovery mode. So every morning again, there are like 5,000 dabbawalas, and they are delivering 200k plus meals with less than 1% of error rate. Now that's superb, and it only happens because of the label on the lid, which station, which floor, and which factory, like which building they need. So all the labeling is so proper that it is able to reach to the right destination at the right time. In Kubernetes today, if you see the default mode, like I said, nvidia.com/GPU1 is integer, like we just give this. But what about the rest of the details? What about the topology? What about the actual device? We are not making GPU the first class citizens within the Kubernetes ecosystem. And this is where there's a project, there's not a project, but the feature inside Kubernetes called DRA, Dynamic Resource Allocation. So Dynamic Resource Allocation has the resource claims, device classes, where you actually can specify the topologies, more set of information. So right now, when you see the nvidia.com/GPU1, that is just labeling on the Dabba Mumbai. You can't deliver it anywhere. But when you start adding more things, adding more topology, adding more information, you treat like as a first class citizen, DRA helps with that. So this is where DRA comes in. So now you have HAMi. HAMi is slicing up the GPUs, making sure everyone is getting the GPUs in the right manner. So you can get like 40%, 40%, 30%, stuff like that. And then you have DRA. DRA actually works with native scheduling. So next up, we have the Kalipili taxi. So you raise your hand and you get, taxi in a minute. It's not your taxi, but you are using it. Understand it. You are using it when you need it. Similar to, we need to use the GPU when we need it and release it back for others to use when they need it. So that's the fleet of taxis. That's the fleet of GPUs that we are living in. So we have the fleet of GPUs. So how do we use those GPUs in a way that there are 5 teams. Those 5 teams can take up the GPUs when they want and release back to the pool. So this is where these auto scaling techniques kind of come in, and the tenant isolation, which we'll be using vCluster for that. So every team gets their own. So in a data center, you have a pool of CPUs and GPUs. You create a Kubernetes cluster on top of that, and then for each team, you create a tenant isolated Kubernetes cluster that they can get, along with the auto scaling strategies that they will be able to consume and take back. So yes, utilization, everything needs utilization, scheduling and scaling. So HAMi, VRA and the GPU fleet. And actually the Mumbai is already living a dream factory. So it's basically just we have to learn a lot from what Mumbai has been doing on the ground level for the software layers and the hardware layers as well. So this is the demo architecture, hopefully, or I don't know, but let's see, kubectl get thoughts -a if it is running, and it should be running, and I can now plug in my mobile phone and hopefully you should see something. Okay, which HDMI I need to plug in? Can we switch to mobile was the keyword that I was given to switch to mobile. I hope it. Okay, so let's take a picture. Let's take a picture. Use the picture. Send to Gemma 3. Okay, Olama call has failed. So which pod is not running? Oh, the pod that is actually has to send, that is not running. So still in pending. So it takes a bit more time to do that, but what it will do is it will run. So you need to trust me on that, but we will not waste time because I only asked for 1 minute extension from them. So this is KubeCon India backup demo when things fail. So this is where that's my daughter's book. My daughter is here and she has been to many KubeCons as well. So you take a picture, send it to Gemma, the model, and then this is the DGX Spark dashboard where we'll see the utilization that goes up in a few seconds. So the utilization goes up. Yeah, you can see the 95%. And when we go back, we'll see the response, so the description. And that is the model which is running on the DGX Spark using HAMi, which is the architecture. And I've already shown you this one, at least I can show you that only for the demo. But yeah, this one is almost running. So kubectl, what is happening is kubectl describe nodes. First we'll look at nodes. And kubectl describe node. So what is happening over here as well? Why this whole thing is happening? Because my laptop is a control plane and I'm using something which is called vCluster in Docker, like a Wine local Kubernetes cluster. So my this is my control plane and this is the GPU node that I have added. That is why you are seeing a 2-node cluster. That is why everything has to be on the same network connected to the hotspot, and the networking takes a bit of time to come back up. And you can see that in this nvidia.com/GPU1, and as soon as all the nodes, all the pods, they get in running state, there will be once this gets, especially this one, once it gets in the running state, it will. Maybe I'll just delete it. I mean, somehow I knew it that the internet will fail me, but it's okay. Only this pod needs to be running for the demo, and only this pod is the one which is in the pending state. So that happens. But yeah, in the end, what it is there is this is vCluster. So when you do vCluster list, so there are 2 vClusters. So what ideally this setup is, I can show you the diagram. So you have the image, you capture the image, and then you go to the MacBook, the control plane, and then it routes the traffic to the DGX Spark to one of the teams. In this case, it has to be the alpha, the pod that is not running yet. But I'll be at the HAMi booth and I can show you the pod will be running in some time. And then it gets all the LLM, the Gemma model, takes the request, does the inferencing over there, it sends back the result into the phone, and we'll be seeing the description over there. And both of the tenant virtual clusters, the team A and team B, they are completely isolated, and they're using the GPU slices powered by HAMi project. So are we there yet with Kubernetes is the question. So one thing I want to tell, Kubernetes is all about the community. While I was doing the demo, I raised 2 PR fixes to the HAMi repository itself because it was not working on the device. So there are 2 PRs that I fixed while doing the demo, and that's how you start building it. So HAMi with its, so Kubernetes with the friends support from the CNCF ecosystem, the projects that are there, it is actually becoming the base layer for building the AI factories, and the work is still not done yet. Jonathan explored in the keynote, like there are a lot of places you have to move in from left to right. So this is where I would say it's you all who have to contribute, and see you at the HAMi booth so that we can do more. Yeah, thank you so much. But at least my friends convinced me to get the recording done, so I had what I wanted to show. Thank you all, and hope to see you.